All right. So today, hold on. Okay. All right. So today, what we're gonna do is this. We're starting a new unit, Unit 7. All right. Even though I probably should have never made it into a separate unit because this unit, well, first of all, it's gonna be short. Like looking at seven, we're looking at 7 school days. Second, that it's actually still systems. It's not systems of equations, but they're systems of inequalities, which means there's going to be a lot of shading going on with two equations. Okay. All right. And then finding solutions within. So, all right, let's get started. And yep, let's see what happens. All right. So let's see. Systems of inequalities. All right. Let me show you what the origins of this particular topic is. Today, let's try to get you to use a calculator, but also try to graph it by hand. Okay. Um, all right. So let's see now. Where did we come from, right? So this was probably a month ago now when we started the last unit in Unit 6, and the thing I said at the time was that the first way to solve a systems of equations is by using, right? So we're talking about systems of equations here. Hold on. So we're talking about systems of equations here, right? Where you got two equations, you graph them, and notice, right, they're both in slope-intercept form. And then you graph them, and wherever those two lines intersect, that one place, there's your solution, right? Ideally, because sometimes you can have no solutions where the lines don't intersect, and sometimes you have infinite amount of solutions, right? Where those two lines are one and the same things. So here we're looking very strictly again at the systems of equations where there's one solution, right? And then when we were to graph this, very straightforward. As a matter of fact, right? The basic question is, what's the instance? What's the only instance where they share the same x and y values, right? So here I've used my trusty TI-84 calculator. All right. Again, always make sure to clear the memory first before you start. But here I got the two equations. Again, take a look. Right. I got the two equations. They're the exact same equations, and I'm gonna graph them. Right. And then if you want to see if you actually want to graph this by hand, you can use the table of values. And as you've already noticed, right, this is where the solution is. Okay. And in the graph, it's the same thing. So it's -3, -4, which is right here where the cursor is. All right, I'm not really even looking at the number. Right? -3, -4, which is where that solution is, where the cursor is flashing right now. Right? Nothing crazy. Right? And jump forward to today, right? The only difference between a systems of equations in inequality are these symbols. So whereas in the last one, all right, let me go back to a yellow highlighter, right? In the past, we were looking at this, right? The equal sign and trying to find one solution. Now we're looking at this. We're looking at inequalities, right? The symbols. Now these I've chosen arbitrarily. I'm not trying to make any special points here, right? Other than to show you that, look, we had equations, now we have inequalities. Now, does actually graphing them or the lines, do they really look that different? No, not at all, right? So here we got the blue one. So this is the Y1, right? If you're looking at the graphing calculator lingo, right? This was the Y2, right? So hence the blue dots that I plotted already and the red dots I dotted already. Now, right now, there's really nothing you should do on your part other than to pay attention. All right, because I'm just going to connect these points with my blue marker. So let me get my ruler. So what I'm going to do is I'm going to connect the blue, connect the red, and then show you where the solution is and where they're different from before. All right, so let's see. So here I'm going to connect this. I should use a thin line actually. Keep it classy. All right. So here I'll use a medium line. Here I got the first line, and I'm gonna label. What was it? Y. Oh, I shouldn't have done that. I shouldn't use a saw. I mean, technically I'm right, but this is y1, right? 2x plus 2. Okay. So here I'm going to write this. Y is less than or equal to 2x plus 2. Now, I got a little lucky there. So you see the line underneath this, right? This is less than or equal to. So the line is going to be solid anyways. Okay? And then, now hopefully, I got to tell you, if we were back in the building already, this is actually, I would prefer to do this in class. Because then you have graph paper and all that stuff. You can actually do it by hand, right? Now, the second line is y is greater than x plus 1. So it's greater than. So I gotta remember, right? It's not a solid line, right? If it's greater than, it's a broken line, right? It's a dotted line. So let me try to connect this without drawing it as a solid line, all right? So that's one thing you gotta keep in mind. Now, I mean, in class, and even when you're doing this remotely, this is why I would encourage you to do this with a pencil, because even if you drew a straight solid line accidentally, you can use your erasers to create the breaks, right? So now, if I want to get really, really professional, I will change this to red, change the line to this, and then just connect them. Okay, so watch this. All right. Wow. Should I make this thicker? Yeah, probably. All right, let's try again. All right. Now, which is funny because you don't need a ruler to draw a straight line like this, but all right, like this. Okay. Now, I'll try to put myself in your shoes and not use this and just draw it straight out. Okay. So just to achieve some solidarity with you guys. All right, so I'm gonna draw a broken line here. Let's say that, and then draw my two arrows like so, and also write the equation. Y is what? Greater than x minus 1. Right? See that? Now, the only thing left is the shading. So this is less than. Wow, how did that just happen? Okay, all right. Well, it's Monday morning, so maybe that's why. All right. Again, if you have a pencil, I would just use a pencil for shading purposes. Okay, all right. Now, for this one, this is greater than, so I'm going to shade above. Okay, all right, I can see where this is going. So, all right, maybe not the best choice of color. All right, now, so let's see. Now, based on this, can you tell where the solutions, right? Because it's not just one solution here, by the way, right? This is not just one solution anymore, right? Because we're using inequalities, which means there are multiple solutions. Can you guys tell where the solution is going to be lying? Right? Where's the solution going to be? Yeah, right here. This whole place. Actually, let me see if I can use my magic marker just to highlight that particular part. Right here. This part, you see where some of these spots turn purple? That's the solution. Okay, so in other words, with systems of inequalities, you don't get one answer. You get a bunch of answers. And where do you find this bunch of answers? Where the shading intersects. So you see how, again, like, right, some of these spots, they turn purple. They should all be purple, but it's right here. Okay, that's how you find the solution. So now, hold on, let me see how I'm doing time. Okay, so More importantly, then, how are we doing on time? Yeah, it's okay. All right, I'm gonna stop after this. Okay, I don't want to make these videos too long after yesterday's. Um, so in other words, so let me use a smiley face. Okay, again, don't use a smiley face on the regions. But okay, so I'll give you an example. So for example, then, yep. So for example, is this the solution here? Let me see. Is 228 or 2 3? 2 over 3 up. I hope you guys can see this. Is this a solution of the systems of inequalities, right? So again, listen carefully. Is this point 2 comma 3 a solution to the inequality, to the systems of inequality? Yes. Why? Because this is right in the section where they both were shaded in. Got that? Right? Let me ask you guys another question. So let's go 4 over 1, 2, 3, 4, 5, 6, 7. Is this part of the solution? Yeah, right? Is this part of the solution? Yeah. Is this part of the solution? Yeah, it's still within the shaded area because this blue line extends forever and ever, right? Now let me ask you guys this. Right here, right on the dotted red line, is that part of the solution? No, it's not, because the line is dotted. You can't include any of the answers on the line. So similarly, this is not part of the solution. I should use a different, actually. Let's use flowers, okay? So this is not part of the solution. This is not part of the solution. So let me ask you guys this. This original point where the two lines actually intersect, is that a solution? Let me point this right here. Right here. Is this a solution? Oh, let me use it. Should I use a different color? Let me put a star there. I don't want to confuse you guys too much. This where the star is that a solution? No. Why not? Yeah, it's on the broken line, so it cannot include that as an answer. Okay? So I hope that that makes some sense. Now, to contrast that with this, is this part of the solution is sitting right on the blue line and they're shading? Yeah, it is. It's part of the solution because that's a solid line. How about this? Yeah. How about this? The axis. Not the axis. It's the y-intercept. Yeah. Now what about this? Is this part of the solution? No, because the two different colors don't shade with each other anymore. Or rather, right? What about this? Right? Is that part of the solution? No. Is this part of the solution? No. Okay. So hopefully that was made clear to you. Um, hold on. What else? Yeah, I basically answered this section in the previous page. So again, summarize 30-second summary, right? What we were used to doing were systems of equations, right? Where if you draw two lines, let's go back to the graph. If you draw two lines, right, they only have one solution. But now that we are transitioning to inequalities, doesn't really look like that anymore. Now, some of you might say, Mr. Ng, can we do that on the graphing calculator? Sure. If you go here and you change the setting, hold on, I'm going to press pause just to make sure that I remember how to do that. Yep, so if you go here, right, if you go to the box here and you press enter, it'll let you change the, now I forgot what that was already. Is it greater than or less than? The blue one, hold on. The blue one is less than. Okay, so it has to shade underneath it. Okay, and then for this one, hold on. For this one is greater than, so I'm going to change that by pressing enter. All right, press enter, enter, and then we're gonna graph it. See what that looks like. See that? All right. Okay, maybe I should have just taken a screenshot of this instead of trying to paint everything myself. But you get the point, right? You see that? Where the blue and the red intersect, that's where the solution is. But not including any answers that's sitting on the red line, but we do include all the answers sitting on the solid blue line, okay, as I explained before. All right. So again, if you had a hard time understanding any part of this, simply rewind and watch this, and that's it. I think that's it. Hold on. Let me go back to the smartboard file. Yep. Okay, and that's it. All right. So, yep. Come back to class, or if you're at home, and start at the homework. Okay. All right. See ya.
OMG, that was so good.